I'm thrilled to introduce Laura Major. Laura Major is the Chief Technology Officer at Motional, a global leader in driverless technology. Laura began her career as a cognitive engineer for Draper Laboratory, where she combined her psychology and engineering skills to design decision-making support devices for US astronauts and soldiers. After 12 years with the company, she served as the division leader for the Information and Cognition division. During this time, Laura was recognized by the Society of Women Engineers as an emerging leader. She is the co-author of the book, What to Expect When You Are Expecting Robots: The Future of Human-Robot Collaboration. Laura, thank you for joining us.
Hi everyone, I'm Laura Major from Motional. I'm the CTO at Motional, and today I'm going to talk to you about scalable AI solutions for driverless vehicles. So first I want to tell you a little bit about Motional in case you don't know about us, and then I want to get into specific challenges with solving driverless technology. And a key part of that, as we all know across the industry, is that data is a key enabler to unlock advancements. And I'll share some unique approaches that we take at Motional in our ML first approach. And then I'll tell you how we're using that to power our path forward. So first I want to tell you about Motional. So Motional is a joint venture between Hyundai and Aptiv. And we're focused on making autonomous vehicles a reality. So this means we're focused in on developing level 4 technology for two applications. First is ride hail, and the second is delivery services. So Motional was formed in 2020 as, a joint venture between Hyundai and Aptiv. And our team is composed of, the teams that were ultimately acquired, by Aptiv from Nutonomy and Automatica. And our team has achieved, many industry firsts, including the first autonomous cross-country drive, the world's first robotaxi pilot in Singapore, and still today we operate, one of the world's most established public robotaxi fleets. We have offices across the globe. I'm in Boston. We have big engineering offices in Boston, Pittsburgh, Santa Monica and Silicon Valley, and in Singapore. We have an office in Seoul for our collaboration with Hyundai, and of course in Las Vegas to support our commercial operation. 2022 has been a big year for us at Motional. You may have read we started a service in a new city in Santa Monica. This allowed us also to expand to include delivery. The service is with Uber Eats, where we do autonomous delivery of meals. We also launched our first rides on our Ioniq 5 robotaxi over the Lyft network in Las Vegas. So now let me share with you the Ioniq 5 robotaxi. So this is our all-electric vehicle that's fully autonomous and again available to the public, to public paying passengers on the Lyft network. You can go to Vegas and ask for a self-driving car, and an Ioniq 5 will pick you up. The Ioniq 5 is, it obviously has won a lot of awards. It was the 2022, World Car of the Year, and we're really honored to have been a part of modifying the Ioniq 5 to enable fully driverless capability. All right, so now let's talk about how we solve the autonomous driving challenge. There are a lot of unique challenges to us in the industry. There are many things, that we have to handle. We can't just handle the nominal cases. We have to handle many extreme cases as well. So, this includes things like unpredictable road agent behavior. Cyclists, in this example, you can see the cyclist weaving in and out of traffic, using lanes in different ways. This extends to other driver behavior and pedestrian behavior. We also have to operate in, a diverse environment and weather conditions. So this can mean, obscuring our sensor views, but also, variable lighting situations. And lastly, we have to be able to, handle and robustly perform across, unusual scenarios. So here's an example, but there are many that we experience in our testing every day that you wouldn't expect to see on the road. Okay, so in our industry, one way that we solve this is that we have to have, multiple sensor modalities in order to achieve or even exceed, parity with a human driver. And so this means at Motional, we have a 360-degree view around the vehicle in camera, Lidar, and radar. And all three modalities are needed to really bring together the strengths and weaknesses of each. There's not a single modality yet that can solve the full problem. Each one brings its own advantages, and by fusing information across all three that we're able to again have human-like detection and prediction of our environment. Okay, and I think in across the machine learning and deep learning community, we all know that ultimately scale wins over domain expertise, and that is definitely true in the autonomous vehicle industry. So machine learning has really grown. It started, with application to the perception problem, more classic, problem of detecting, objects and behavior in the environment. But now it's expanded well beyond perception. So we use it to predict, behavior of other agents in the environment. It's used to determine specific actions in different scenarios, as well as other things that are not, on the critical path of the safety critical part of the AV stack. Things like HD map, being able to detect, when there might be a change in the environment that needs a map update. And also things like remote vehicle assistance, being able to develop recommendations to a person so the person can help unblock an AV when it encounters a new scenario. But as we all know, machine learning is only as good as the data that's used to train the machine learning models. And so at Motional, we recognize this, and we recognize the need for richer development of richer data sets and sharing of those data sets to fuel the development across the industry. So we've seen this, across other areas, ImageNet, classic example, where the development of this data set and sharing of that data set is really what, enabled huge advancements in deep learning. And so, with Kitty, we had a multimodality data set available, and we used that in development of our early techniques. But we also recognized that we needed more. We needed broader scale, and we needed real autonomous driving data. So we released New Scenes back in 2018. This was the world's first publicly available real autonomous driving data set. And it's been used broadly across the industry. You can see here, it has over 1 million camera images, 500,000, Lidar sweeps, a lot of annotation, richness of the environment. And we really, pioneered this data sharing culture that has now extended, across the industry. We see many others, Waymo and Argo and many other examples of, companies, developing data sets not only for their own use, but also sharing them to fuel the research and also help others across the industry evaluate their techniques. But we didn't stop there. This has been an ongoing initiative at Motional, and we've expanded it beyond that initial data release in 2018 to develop additional data sets that can help with perception development, but also prediction and now planning. Last year, we released the world's first benchmark for AV motion planning, and this is used in many competitions now. And so by pioneering this culture of data sharing across the industry, we've really seen, a high use of these data sets and improved performance across the industry. All right, so now I'm going to talk a little more about our specific approach at Motional. So, I think across the industry in the past, it was about, developing the right algorithms and really, trying to, gather as much data as possible and really increase the training data volume. And that was enough for proof of concept. That got us, got the industry started, allowed us to create some great demos. But in order to get to a true driverless capability, it wasn't enough. So now, the focus is on not just, increasing the volume of data, but getting the right data. So this includes, finding rare objects across our, the data that we collect on the road and upsampling those in our training data and in our testing data, and also identifying challenging scenarios where we want to, again, have more rigorous training and testing. So some examples, that we see are things like, a cyclist carrying a surfboard, or, really unusual, driving behavior around a construction zone. And so we take this data, and ultimately, discover it in our data set, but then it's also about the right infrastructure. We need to be able to accelerate our learning process. And so make sure that with every, mile we drive on the road, we're really learning from that as fast as possible and improving our autonomy performance. So our approach to this at Motional, we've developed what we call the continuous learning framework. And so this allows us to, from all of our on-road driving data, we can mine this data and discover these, again, rare scenarios or areas where there are challenges or issues with our performance today. And then based on that, we can, upsample and incorporate more of these scenarios into both our training data. So we annotate and add it into our training database, as well as our test corpus, so that we can use that to evaluate our capability, not just once, but every time we do a new software release. So this really allows us to, improve the overall performance of our stack and to accelerate, the timeline for developing autonomy improvements. Okay, so here's an example. As human drivers, it can be hard to figure out, how to, adapt to and negotiate different cut-ins from other vehicles. So when a vehicle is coming into our lane, are we in their blind spot and they don't see us? Are they going to try to cut over to another lane after they enter our lane? Are they going to come to a stop or keep going? These are things, again, as human drivers that are challenging. And of course, it's challenging to, develop, approaches to handling these situations, because you want to balance, being conservative and, making sure that you're providing additional spacing in case the vehicle that just cut in front of you, needs, it's going to come to a stop or it's going to create a safety issue, but also comfort. If you slam on the brakes every time a car changes lanes into your lane, that's going to create a really uncomfortable ride for a passenger. And so here's an example where our software developers, when they discover these situations, they can go into our database with all of our data that we've collected from public roads and search for scenarios that are like these. And they can then get results and use those again to build up a training set or a testing set that they can use in developing and improving our solutions. Okay, here are a couple examples. Ultimately the proof's in the pudding. We need to have a reliable, robust AI solution. So here's one example from Las Vegas of our perception approach. So you can see our system, encounters really complex, activities every day on the road. There are a lot of, other vehicles around, these multiple lanes of traffic. There are different types of vehicles. You see motorcycles, but we see everything from, trucks carrying billboards to three-wheeled, vehicles and so on. There are also, a lot of pedestrians. So you can see, the pedestrians here on the sidewalk, and they interact and are often, walking around different infrastructure that may look like a pedestrian. So you can see that here in green, the bollards, the shorter poles are seen frequently in Las Vegas. So all of this, we need to understand all of these elements in our environment in order to be able to, make the best decisions and have safe and smooth driving behavior. So another example is from our prediction system. So again, by having large data sets and training our models, we're able to have more robust prediction of other the actions that others may take in the environment around us. So you can see here other vehicles, at a four-way stop. It's always hard as human drivers to know, is the car going to proceed before me or should I let them go? And so again, we can collect a lot of data around this, and we can train our system to more accurately predict how these other drivers will behave, which positions our stack to make better decisions. Okay, but then you may ask, is this enough? We're developing, a safety critical system ultimately. So again, it's not enough to perform well most of the time. We have to perform well all of the time. And so, a question we often ask ourselves is, how can we make these ML-based solutions perform even more robustly? And two, key areas that we focus on are, one is sensor fusion. So we use what we call sequential sensor fusion, which brings about strengths and weaknesses across early fusion and late fusion across these three sensor modalities, so that we can fuse this data in a computationally efficient way to get better outcomes. And then second is, we need to be robust to approach, have robust approaches to, handle objects that we've never seen before or that we've rarely seen. So I'm going to talk about two techniques we use here. One is augmented reality, and the other is to not just learn objects in the environment, but also learn where there's free space that we can safely navigate through. Okay, so first, sensor fusion. So I described, we use this sequential sensor fusion. And first I want to show an example of why we need this. So you see in the upper corner here an example of, in a Lidar and camera image side by side for this situation where you have a couple poles and you have a pedestrian walking between them. You can see that very clearly in the camera view. In the Lidar view, you have very accurate information about, depth, estimation to each of these objects, but it's really hard to tell what type of object it is, even with a lot of training data, right? And it can be hard. It can be, hard to distinguish between a person and a pole, for example. And so, one of these sensor modalities alone isn't enough. And so we've developed, a number of techniques. Here I'm going to show you one we call point painting that can combine information across these sensor modalities in novel ways to, again, have a more accurate detection than we could have from either. So in this example, from the camera view, we were able to do, robust segmentation, semantic segmentation of the environment. So you can see, here we're able to pull out, we see there's a car, we see there's a bicyclist, and we can identify those objects in the scene. Then we can combine our Lidar data with this semantic segmentation and paint the Lidar points on top of these objects that we can, very clearly visually see in camera, so that we, now we can combine the accurate depth perception with the object classification. And again, we get a better outcome than if we had just used one or the other. So this is one example, but we do this. We also combine, we do the reverse, combine Lidar to make, our image semantic network better. And we also fuse radar into both. And we ultimately have two detectors that feed into a tracking system that, again, has more more robust performance than if we, used a different approach. Okay, next. So that doesn't answer though. What if you come across an object that you've never seen before, or you only have a couple examples, in the training database to go off of, to train on and test against. And ultimately, the long tail problem, it can't always be effectively mined. You don't always have enough of that data. So one approach could be to develop, a full, sensor simulation to really try to simulate the world. But we know there's a lot of challenges with creating, the right level of fidelity of that simulation to get the type of results that are needed. And so we take a different approach at Motional, where instead of trying to create, a full simulation of the environment, we build models of these objects that are rarely seen in our environment, and then we can place them into our real scene. So we get the richness that comes from, real log data, but we add in, objects that may not be there in those scenes frequently enough for us to train against and test against. So in this example, simple one, we have a spherical object that we placed here near, an area where you may, pick up or drop off a passenger. So again, it's, a way of, adding in, a variety of objects into many scenes, and you can then scale that up and really upsample your database, for these unusual objects. But turns out even with our continuous learning framework and this augmented reality solution, there will still be the potential for additional long tail scenarios that we haven't covered through either approach. And so we need to protect against that for, again, a safety critical system. And so how we do this is we also apply machine learning to not only detect the objects in our environment, but also to detect area that is occupied and unoccupied, or what we call free space. In free space, in our approach, which you can see here with the pink, the picture in the middle, includes both the road and the sidewalk. And the reason for this is we need to capture all the activity that could ultimately affect our performance on the road. So often you see objects like this mattress here that are on the sidewalk, but they might jut out into the roadway, and we might need to navigate around them. Or you can see, pedestrians who might come on and off the sidewalk and the road. So we want to be able to capture all of that as well. And so, we've developed an ML approach where we have free space pillars that, we identify as areas that are occupied and that are not occupied, and the non-free space pillars are areas that are occupied. And we combine that with our understanding of the environment that we get from the previous work I described in order to, make more robust decisions about where it's safe to drive. Okay, so that's a little bit about our technology and our approaches, to creating a scalable, robust AI solution for autonomous driving. But now I want to share how all that's coming together to really, fuel our path forward. Motional, we're, really proud of our approach to have, started a commercial, operation early. So in 2018, we started operating a publicly available ride-hail service in partnership with Lyft in Las Vegas. So it was fully open to the public. Anyone can take a ride through their Lyft app, and anyone can rate their experience. That's really been a part of what we've done. We've wanted to gather this feedback, early, and use that to iterate on the development of our solutions across generations. And so this allows us to really make sure we're building a system that public passengers enjoy and are delighted to ride in and ultimately trust. And I'm really proud to share that we've given over 100,000 rides, and 9 out of 10 of those passengers, reported that they would ride again. And 95% of the passengers gave their experience a 5-star rating. Another benefit of this commercial operation is allowed us to learn a lot about how to operate, an autonomous vehicle, operation at scale, and really be able to, develop those capabilities so that we're ready to scale going forward. So it's been a lot of activity over the last couple of years, and a lot coming ahead for us next year. So as I mentioned, we this year was the year we put the Ioniq 5 robotaxi onto the Lyft network and made it publicly available. And next year is the year that we will be launching our fully driverless service. We then will be scaling to new markets, so more to come about that. And in future years, we will continue to scale globally. Today we operate in all of our development cities, as well as Santa Monica and Las Vegas. And we will also, continue to launch new partnerships to enable, not only ride-hail, but also delivery services. And we work on future generation platforms in parallel, while also bringing this system, to the fully driverless service. All right, thanks so much for tuning in today. Here's some information if you want to get in touch with us at Motional, if you're interested in some of our opportunities, or if you're interested in connecting with me directly. We welcome that. I think our team, the talent on our team is really what drives me and drives our team forward. So would love to hear from all of you. Thank you.